Good morning students. We'll continue the previous class. In that previous class I was saying you about the rainbow. There we discussed about the primary rainbow and now we are going to discuss about the secondary rainbow. I said the secondary rainbow is going to take place when those light rays going to enter from or through the bottom portion of those falling raindrops. Look here. Here this light got entered through this first raindrop from its bottom portion. See here. Here this light ray entered, it moving from rarer medium to denser medium. Instead of moving straight, it bent towards the normal. Okay, fine. Here a refraction phenomena takes place. Next, this light ray is moving in that denser medium. Okay, yes, it got incident here. This light is coming through the denser medium. What happened here? You see here that came through denser and bounced back to the denser. What happened here? Here TIR phenomena happened. Here TIR takes place. Okay, came through denser, bounced back to the denser. It is TIR. One TIR happened here. One refraction. Next, this refracted light ray, okay, or this reflected light ray, not refracted. It is now reflected. This light ray here got reflected. This reflected light ray got incident at this point. And again, what happened here? You check out. This light ray going through the denser medium and bounced back to the denser medium only. Again here TIR got takes place. Have you understood? This is second TIR. Then this light ray, this reflected light ray came and got incident here. It moving from denser to rarer medium. Here what happening? Here a refraction happening. Here a refraction happening. Two TIR, two refraction happened here when light entered through the bottom portion. When it entered through top portion, there we see two refraction, one TIR. There we found one spectrum in which red color was at the top and violet was at the bottom, that we called as a primary rainbow. Here in this one, light entered through the bottom portion. So what happened here? Here there are two refraction and two TIR. Because of two TIR and two refraction, what happening here actually? You see here there is observed when those light rays getting refraction finally here, okay, they been separated because of dispersion. Here which color is reaching or which color is received by that observer? From this light ray, that violet color is going to received by that observer. Then remaining colors are moving somewhere here in the atmosphere. Except that violet remaining are somewhere here in the atmosphere. That violet only got received by that observer from that first raindrop. Similarly, at that time, same phenomena taking place through the second water droplet. At that time only, light ray came, got entered into second water droplet or raindrop. Here a refraction there, here TIR, and here one more TIR, and again finally here the refraction there. Here what happened? You look here at this point. Here red, between red and violet, this is violet. Between these two, still 5 colors are there. Okay. See here, from this water droplet, red color is going to They are not going to received by the observer. See, look in this diagram. From first water droplet, violet reached that observer, and from that second one, red color reached by that or received by that observer. Here he going to get one spectrum from different raindrops. In that, by some other water droplets, by some other raindrops, some few other colors he going to get. Somewhere here in this region, he going to see one spectrum. In that respective spectrum, which color is at the top? See here, violet color is at the top, red color is at the bottom. See, here he got one spectrum. In that, red color is at the bottom and violet is at the top. That such spectrum we call as a secondary rainbow. This is only the main difference between primary rainbow and secondary rainbow. Okay, in a primary rainbow there is a red color at the top and violet color at the bottom. But in this secondary rainbow, violet is at the top, red is at the bottom. This is going to happen because of two TIR phenomena in secondary rainbow and one TIR phenomena in primary rainbow. Have you understood? This is about the discussion about, this is discussion about the concept called rainbow. Okay, yes, this is one of the natural phenomena is going to take place due to that sunlight. Okay, after this natural phenomena, now we are going to enter into the optical instrument section. Here there is optical instrument section in our textbook. Optical instruments. Here many optical instruments are there. See here, our eye is also one of the optical instrument, like microscope there and next telescope there. Eye, microscope and telescope, these we call as optical instruments. The instruments which are going to produce the images of different objects, which we call as optical instrument. Before here we are going to start about this section, optical instrument, we should know few things about our eyes. Eye is a very important here in this our discussion. See here, eye is being with some few major parts. Okay, already in previous, in long back class I said eye is being with a biconvex lens. In eye there is a biconvex lens. Here somewhere here I have drawn the diagram of eye. Eye is looking like, we imagine it like a spherical shape. Okay, this is completely eye. Here at the front side, here like this type, there is a biconvex lens. This is a biconvex lens. Okay, that is very important part of our eye. In front of that eye there is a cornea. Okay, curved layer is there which we call as cornea. Many parts are there. Just we should know some few important parts of the eye. Here, just at the above and at the bottom, at the top and at bottom, there are ciliary muscles. There are ciliary muscles. These are a very important part of this human eye. These ciliary muscles, which are at the top and at the bottom of that biconvex lens, okay, these ciliary muscles are going to stretch or they are going to compress the eye lens. That eye lens is flexible. These ciliary muscles are going to stretch or they are going to compress that eye lens. Why they are doing that, later we'll see. letter I. See next, those we call as ciliary muscles. Then next, behind that convex lens. This is front part, this is back side. This is biconvex lens. Here ciliary muscles there. This is lens. Here cornea is there. Then beside, behind that lens, here there is a curved screen-like layer. There is a curved screen-like layer which we call as retina. Behind that biconvex lens, there is a curved portion which we call as a retina. Retina. This is retina. Okay, that is acting like a screen. Why we call screen? On that retina portion, images of different objects are going to form. Images are going to form on this, so we call or we imagining it as a screen. Okay, fine. To that retina, there are nerves called as optical nerve. Okay, there are optical nerves which are in contact or which are connected with that retina. These optical nerves are in contact with the brain. Actually, I said already what happening here in this eye. How we can see the nature around us. Already I said. See, when we look on any object, if we can able to see it means what? From that object light rays are coming. From that respective object light rays are coming. From this marker, I can able to see this marker now means what? From that marker light rays are coming. That markers, re-emitting the sunlight and all already we discussed. Sunlight coming, falling on that marker, marker absorbing and re-emitting. Yes, those re-emitted light rays entering into our eye. Firstly, they going to enter into that eye lens. When they entered into eye lens, they get a refraction phenomenon. Thereafter, all those refracted light rays are going to meet on retina. On that retina, where they will meet, there they produce the image of this object. When they got met on that retina, then there is a signal from this optical nerve to the brain as there is an object. Getting what I mean to say? When all those refracted light rays are going to meet on retina, then there is a signal from that retina to the brain through optical nerve. When brain receives that signal, then brain will feel there is an object. Have you understood? This is happening. See now here, this is about eye, how that eye is going to produce the images. See here, before we going to discuss about optical instruments, we should know about some few concepts, two concepts. One is power of accommodation of eye. Power of accommodation of eye. What it means, we should know. One more is there called as visual angle. If we know these two concepts clearly, then easily we can understand those optical instruments which we will study later. Yes, fine. One thing I will ask you, you see here. See, suppose if I take this marker too far away from my eye, too far, yes, I can able to see that. As I take it near to my eye, I can able to still see that object. Getting what I mean to say? Suppose imagine if it is too far, I can able to see that. As that object coming near to my eyes, I can able to see them. Yes. As it comes very close to eyes, very close to my eye, I can see. Yes, I can see. But thereafter, crossing one particular point, when this approaching object is going to cross, when it crosses that particular point, then we going to see that image as a blurred image. I mean, we going to see that object with blurred shape. We can't see it clearly. And what happened? Up to certain point, our eye can able to see that marker. When it crossed that point, then we unable to see that. What is this? See, one more thing is that. Now this marker easily we can see. If we be with a very minute, very small object, okay, at that time we going to see those objects with a little bit strain. We can't see it clearly. We seeing that bit blurred. Okay, if object is very small than that, then we unable to see that. If object is very small, even though it is brought near to your eye, at that time you unable to see that. Why you unable to see that very small object? Why you had seen blurred image of this object when it brought very near to your eye? Why? Question arises. Mean what? When it was too far, you can able. As it comes, you can able. When it comes very close to you, at that time you will feel a bit strain in your eye. At that time you can't see it clearly. Mean what? That our eye being with some conditions. It has some conditions. According with that condition it is working. It has its own condition. What it means? Condition means what? See here what I mean to say. Eye has 2 points. Eye has 2 points called as a far point and a near point. Far point and near point. Far point means what? The point, the farthest point up to which I can able to see the objects clearly. Yes, object is here, I can see clear. If you take it away, yes, you can see it clear. There is one farthest point. There is one farthest point. Up to that, your eye can able to see that object. That point we call as a far point. Have you understood? For normal eye, that far point, that farthest point is infinity. Means what? Up to infinite distance, normal eye can able to see the objects. Getting what I mean to say? That we call as far point. Up to infinite distance, normal eye can able to see the objects. Then next one more is there, near point. Near point, I said already, when it was too far, as you bring it near to your eye, that going to see it, when it crosses one particular point, at that time your eye was not able to see it clearly. Mean what? From our eye up to certain point, between that point and your eye, if object is there, then that eye is unable to see its clear image. I mean what? Now I am talking about near point. Near point means what? The nearest point. The nearest point up to which I can able to see the images of objects. From farthest point to one nearest point up to which if that I can able to see the object clearly, then we can call it as a near point. Getting what I mean to say? Look here, I have drawn here in this is eye. Okay, AB is like this type marker. It is an object. Imagine this is your eye. Here this is the optical center. I mean geometrical midpoint of your eye lens. Okay. Yes, this is a principal axis. Somewhere here, AB is an object. It is at infinite distance. Okay, when it is at infinite distance, then that your eye can able to see it. Okay, as that object brought closer to that eye, it can still able to see that. When it reaches one particular point, at that particular point, eye still can able to see that object. If object is brought too closer to the eye, then eye is going to see its blurred image. Getting what I mean to say? What happening there? I mean, this eye has 2 points. One as a far point, another as a near point. If object is between these 2 points, if object is between infinity and that point, okay, that I mentioned as a D symbol, that near point we are going to represent with the symbol capital D. Even we call this near point as a least distance of distinct vision. Least distance of distinct vision. Getting what I mean to say? I mean, if object is beyond that least distance, then I can able to see it. Okay, for normal eye, it is about 25 centimeter. From our eye up to 25 centimeter. If object is in between our eye and 25th centimeter, then our eye is unable to see the clear image of that respective object. This is 25 centimeter from our eye. Okay, this is 25th centimeter point from our eye. If object is here in between the 25 and our eye, then our eye is unable to see its clear image. Then that object is looking blurred. Why? What happening at that time? We tell later. Okay. When if this object is beyond that near point, beyond the near point, between that near point and infinity, then I can able to see it. What happening? If that object is beyond that D point, beyond that near point, then those all light rays which are coming from that object and they going to get refract from the eye lens and they going to produce its image properly on retina. They going to produce its image properly on retina. That's why there is a signal to the brain as there is an object. Getting what I mean to say? If object is between near point and far point anywhere, then that eye can able to get the image on retina. So we can see. If object comes in front of that D point, then what happening? Then all those light rays which are coming from that object are not going to form the image on retina. Then there is no proper signal to the brain. So we feel a blurred image of that respective object. Have you understood what I mean to say here? That eye has certain conditions. I mean, for normal eye, if object is between 25 centimeter and that optic center, then eye is unable to see their clear image. If object is beyond near point till far point, then eye can able to see the object clearly because their images are properly going to form on retina. So we feel clear image. Have you understood? Eye has 2 points. One is near point, another one is far point. Okay. For you should know that value also. It is 25 centimeter for normal eye. Yes. One more thing is here. What mean power of accommodation of eye? What it means? Look here. See here. What I need to see. The ability of the eye to produce sharp images of objects which are at different position. The ability of the eye lens to produce the sharp images of different objects at a different position. Getting what I mean to say? On the retina, always the ability of the eye lens to produce these sharp images of distant objects always on retina is called as power of accommodation of the eye. What it means? See here, what I mean to say. Look here, this is the lens. When we are going to feel the presence of object, when the image of that object is going to produce on retina. I mean, the distance between, I already said, retina is behaving like a screen on which we getting image. Image should be always on this retina, always here on this retina. Here it is optical center there. I mean, this is optical center, always images should be on retina. Mean what? That image distance is fixed. That image distance is fixed. Getting what I mean to say? When we get image on retina, then only we can see. Getting what I mean to say? That image distance is about 2.5 centimeter. The distance between optical center of our eye lens and the retina is about 2.5 centimeter. This is fixed. Okay? This is fixed. The eye is not going to get changed their shape like this. That is fixed. Okay? This is eye lens, optic center, this is retina. This distance is about 2.5 centimeter. It is fixed. I mean, image distance is fixed. See here. If object is at D point, then we can see it. Mean what? Its image formed on retina. Yes. Image distance is fixed. From here to here it is what? Object distance. At that time that lens has certain focal length. Getting what I mean? Now you see here. Suppose if I take object somewhere here. If I take object somewhere here. This is A and this is B. Now what happened? Object distance got changed. Previously object was here, image got produced on retina, image distance was this much, it is always fixed. At that time, lens has certain focal length. You should remember that lens formula, that is 1 by f is equal to 1 by v minus 1 by u. This is lens formula. Okay, you should know this lens formula. What I mean to say? When object was here, at that time there was certain object distance, certain focal length, fixed image distance. Now as you taken that object away, then what happening here? Then object distance is different. Object distance is different. Image is fixed. Then what should happen here? What has to take place here? That focal length, you see the relation here. This is fixed. As this changes, it has to change. Look on this formula. Image distance, this is fixed. As you change this object distance, there should be change in the focal length of that lens. How both are directly proportional. As you increase object distance, there should be increase in focal length. As you decrease the object distance, there should be a decrease in the focal length of that eye lens. Means what? When you look on different objects. Now I am looking here on this marker which is here.